This is the first of the practice questions for LV03K, which is the exam for the electrical systems on motor vehicles. As you can see from this first question, it says the diagram shows 3 resistors, and you can see them here, R1, R2 and R3. It gives you the values. I'm just going to bring the values in so it's just easier to see. So R1 is 1 ohm, R2 is 0.5 ohms, so half an ohm, and R3 is 1.5 ohms. And the question is, what is the reading on the ammeter when the switch is closed? So let's just get rid of the question, and this is going to be one of those questions where we need to use our Ohm's law triangle, which I've just brought in there. And you guys know that it's volts, intensity of current or amps, and resistance over here, which is measured in ohms. I'm just going to clear those symbols out so that we can put in the values that we do know. Now we know that we've got a 12-volt battery, so let's put 12 in the top of the triangle there. And we now need to calculate the total resistance that we've got. Now, because these resistors are in series, that means they're one after the other. All we have to do is to add the value of those resistors. So there's the first one is 1 ohm, the second one is 0.5 ohms, and R3 is 1.5 ohms. So as I say, just add all of those values together, and if we do that, it comes to 6. So our total resistance is 6 ohms. Let's just put that into our triangle. And basically now what we have to do is to find the current here. What we need to do is to divide 12 by 6. Let me just write that in there. 12 divided by 6, or 12 volts divided by 6 ohms, equals 2 amps. Let's just put that in our triangle there. So there you go. The answer is 2 amps. And essentially what you need to know is the position of the values, that where they fit into our triangle. So make sure you know that. And yeah, the rest of it should be fairly straightforward. Okay, this is question 2, and as you can see, the diagram is identical to question 1, but now the value of the resistors has been changed. So let me just bring in the resistors. R1 is now a 2 ohm resistor, R2 is now a 3 ohm resistor, and R3 is now a 1 ohm resistor. And the question is now, what is the reading on the voltmeter V2, this voltmeter here, when the switch is closed? So we're now very much focused on this part of the diagram, and what we need to do is use our Ohm's law triangle to try and calculate the volt drop across R2, i.e. what would show on this voltmeter here. So I'm just going to clear the text to create some space and bring in an Ohm's law triangle. Now we know the layout, we know it's volts, amps and ohms, so I'll just clear those symbols. And what we can slot in is whatever information is available to us for this part of the diagram. Now we know that the resistance is 3 ohms. So let's just slot that into our triangle. And what we now need to do is to calculate the current, or we need to know the current that's flowing through this resistor in order to calculate the volt drop across there. The problem is that we don't know the current flowing through here, and this triangle here is just for this part of the circuit. So I'm just going to put a circle around there. But what we can do is we could calculate the current flowing through the entire circuit. I'll just show you that there. Because whatever current is flowing here will also be flowing here. We can't have a different amount flowing here to what's flowing here. So if we calculate the current flowing in the entire circuit, by definition we would know what's flowing through this resistor, and we can come back and slot that into this information here. So I'm just going to bring in another Ohm's law triangle. Now this one is for the entire circuit. So I'm just going to sort of highlight that in green so you can see the difference. And I'll get rid of the symbols and slot in the information that we do have. So we know that we have 12 volts available for the entire circuit, which, as you can see, I've just slotted in there. And we could also work out the resistance for the entire circuit. So it's 2 plus 3, which is 5, plus 1, which is 6. So let's just put the resistance as 6 ohms in there. Now that means that the current flowing through the circuit is 12 divided by 6, which is 2. So I'll just bring in the 2. There it is. Now that we know that there is 2 amps flowing in the entire circuit, we will know that there must be 2 amps flowing through this part of the circuit. So we can bring our 2 up into this diagram here. Now the question, if you remember, was what is the volt drop across R2? In other words, what would show on V2? And that would be 2 times 3, which is going to be 6. Okay, I haven't actually put that into the diagram, but hopefully you guys can see how you work it out. Let's move on to the next question. So question 3 is the unit of electrical resistance is the, and we've got our 4 options. So by now most of you should know that electrical resistance is measured in ohms. So the answer is B. Electrical resistance is measured in ohms. Just while we're here, a coulomb is a measure, it's a unit of electrical charge. All right, so nothing to do with resistance. A volt is a measure of electrical pressure or potential difference. In other words, the force that's pushing electricity through a circuit. And a watt is a unit of electrical power, or just a unit of power actually. We can measure all sorts of power in watts. So yeah, question 3, unit of electrical resistance is the ohm. Okay, so question 4 is a lamp has a poor earth connection. This will cause the lamp to blow the circuit fuse, the lamp to be dim, or finally the lamp to be brighter. Okay, so I'm going to bring in an image. I apologise for the quality of this. I drew it on my kitchen table. Okay, so what I'm trying to show you here, this is my car battery. So it's giving us a DC supply of electricity. And we're using the bodywork of the vehicle, the car, as our earth return. So the current will come from the positive side, flow through the filament of the lamp, and then return to earth via a wire that's bolted to the bodywork. Then it will travel through the metal of the bodywork and then back up through this cable to complete the circuit and return back to the battery. So that's fairly normal. Basically, if we imagine this is a 12-volt battery, we're going to have 12 volts worth of electrical pressure pushing electricity up to the resistance here. And then after the resistance, the pressure should have dissipated and become 0. Let me just show you that on another diagram here. This is my water analogy. Sorry, again, apologies for the quality of the image, but imagine this is a hose pipe squirting water at a brick wall. So you can see the water is coming out of the hose pipe under pressure. So here you can visualize the pressure. The brick wall is resisting the flow of electricity. So once the pressure hits the resistance, it trickles down, forms a puddle down here, and in the puddle the pressure is 0. So we have pressure up to the resistance and then 0 pressure after the resistance. Okay, so just bring in my previous image. What happens is if we have a bad earth connection, so what I've done here, hopefully you can see that I've coloured in some rust. All right, so my bolt through the bodywork of the car has gone rusty. Now the rust offers an additional resistance. It's difficult for the electricity to flow through the rust. So starting at the battery, we will push electricity up to the first resistance with 12 volts worth of pressure, and then theoretically there should be zero resistance, so it should be like it's flowing in the puddle. But because I've got this additional resistance here, I'm having to build up pressure to push through the rust. Okay, so now instead of having a drop of 12 to 0, I would have a drop of 12 down to whatever is required to push through the rust. So it wouldn't drop as much, it wouldn't drop by 12 volts, and therefore my lamp would be dim. So hopefully you can see that the correct answer is C, the lamp would be dim. Question 5 is, an LED is a type of, and then we've got a diode that emits light, transistor that emits light, diodes used in rectifiers, or electronic sensor. Now, an LED is a type of diode. I'm just going to show you an image of a diode. I've brought one in here. So diodes look a bit like this. This is the symbol that we use in circuit diagrams, but this is an actual component. This is a picture of a component. And what diodes do is they act as a one-way valve, if you like. Current can flow through the diode in one direction, but can't get back. It's blocked. And that's what diodes are usually used for. Now, it just so happens that some diodes, when we put current through them, will give off a kind of light. They start to glow. And I've just brought in a couple of examples here. These are the more traditional type, the older fashioned, if you like. And as I say, when you put electricity through them in one direction, they happen to glow, they give off a bit of light, and we've developed that characteristic, and now we have very powerful glowing LEDs, and they are referred to as light emitting diodes. They give off a kind of light, they emit light. So the answer is, an LED is a type of diode that emits light. A light emitting diode. Let's move on to question 6. What is the most important reason why you should report to your supervisor a probable delay in completing a vehicle repair by the promised deadline? The answer here is, I'll just bring it in for you, it will create poor customer relations. All right. Basically, if you have a problem that's going to cause a delay, if you've promised a deadline for your customer, in other words, if you said, I'll have your vehicle ready by midday, that customer will have made arrangements, got a taxi back to your garage or whatever they've had to do, and they've made a commitment to be back to you by the time that you promised. So if they get to you and then that's when they find out that there's been a delay, they're not going to be very happy, right? And that's when they start to tell other people about the poor service that they've received from your garage. All right, so it's important that you tell your supervisor so that the supervisor can contact the customer and let them know that there's going to be a delay, and they might not be that happy about that, but they'd be happier than finding out when they turn up to collect their vehicle that they've got a 3-hour delay. Okay, let's move on. Let's have a look at the next one, question 7. The light from a fog light is dim. Which of the following is not a possible fault? Now, the important thing is to realize that we're looking for something that is not a fault. Now, a corroded earth connection, that, as we've just discovered, will cause the light to be dim. So that would cause a problem. An open circuit supply cable. Okay, let's just make sure we understand what this means. I'm going to bring in a diagram of a switch. Now, hopefully you can see that this switch, this is the symbol in an electrical circuit, the switch is open. And hopefully you can see that current wouldn't flow through an open circuit. All right, so if the circuit is open, the light wouldn't even work. It wouldn't be dim, it just wouldn't work at all. Okay, let's have a look at the, so therefore that is the correct answer, by the way. Let's just check the C and D. A corroded light reflector. So if the silver part behind the glass has rusted and corroded, then the chances are it won't reflect as much light, so therefore your lamp would be dim. A corroded supply cable, very similar to a corroded earth cable. It's going to offer a resistance and therefore less electricity will flow through, and so by definition our lamp will be dim. So the correct answer is B, an open circuit, because if it's open it wouldn't work at all. So let's have a look at question 8. In a 12 volt system, the battery voltage when the engine is being started should not be less than, and then we've got our options of 10 volt, 14 volt, 2 volt or 12 volt. Now what I'm going to do now, I'm going to show you a video that we made in the workshop, and then I'll come back and we can look at answering this question. So today we have a Hyundai i20. The customer's owned this car for a couple of years and has said she's struggling to start the car in the morning. It turns over very slowly, it's a bit sluggish. So she's asked us to check the battery out. So we're going to start by removing the surface charge. So Dammy, can you switch the lights on for a couple of seconds? Right, this will take off any surface charge on the battery. And then Courage here is going to check the voltage. Just switch the lights off now, Dammy. So we needed those on for usually about 30 seconds, half a minute or so. Okay, if you can just test the voltage now then, Courage. Okay, and as you can see, Courage is checking the voltage, and we currently have 11.83. So it's below our 12 volts. So that's not a good sign, and we're already suspecting this battery. Right, what we're going to do now is crank the engine and in an attempt to start it, and we should monitor this voltage here. If it drops by more than 2 volts, so i.e. if it drops to below 10 volts on the display, that would also indicate that the health of the battery is not good. So Dammy, can you crank it over for us? Okay, stop, and you can see that it dropped down to way below 10. Crank it over. Okay, stop. Okay, having watched the video, you should be aware that when you start the engine, the voltage shouldn't drop any more than 2 volts. So if we started with 12, the minimum we should have during cranking is 10 volts. So the answer is A. Question number 9 is, in an electrical circuit, electrons flow, and then we've got our 4 options. So they flow when the circuit is open, from negative to positive, when there is no continuity, or from positive to negative. Let's eliminate the ones that are obviously wrong. And the first one I think you'll find is wrong, because if a circuit is open, the electrons can't flow. There's our switch, and you can see the switch is open, so there's no way any electricity would flow or any electrons could flow in that circuit. And that's also true of C as well, when there is no continuity. Now this line, or the circuit, is not continuous. It is broken. The switch has broken the circuit, so we have no continuity, and therefore no electrons will flow. So A and C are definitely wrong. Now all we need to decide is it B or D? So do electrons flow from negative to positive or positive to negative? Now I'm just going to bring in a snippet from one of my previous videos. and I'll just run this in a moment. But what I want you to look at, I just need to explain a couple of things. These cans are representing the electrons, and they will move from negative to positive. But what we actually see is this space moving from positive towards the negative. So as the electrons move from left to right, as we look at it, so from negative to positive, you'll see the empty space appears to be moving this way. And that's why we used to think that electricity moved positive to negative. So let me just run this. So there you can see the electrons moving negative to positive, but the empty space appears to be travelling positive to negative. So in actual fact, electrons move from negative to positive. The answer is B. Question 10. In a 12-volt lighting circuit, 4 lamps are connected in parallel. If each lamp is rated 6 watts, what current will flow in the circuit? And then we've got our 4 options: 48 amps, 0.5 amps, 24 amps, or 2 amps. Well, first off, I'm just going to bring in an image of a parallel circuit. So we have our live line, our live input, and our earth return. And then we're going to put our 4 lamps. There's 1, 2, 3, 4 of them arranged in a parallel circuit. Okay, so what we need to be able to calculate the answer is we need our Ohm's law triangle, and this time it's the one with watts in it. So watts, volts and amps arranged in our Ohm's law triangle like this. Now we need to calculate the wattage in this circuit, so I'm just going to blank out the watts there, and as I say, this is what we need to calculate. Now what we know is we have 4 lamps and each of them is 6 watts. So basically we just need to multiply the wattage by however many lamps there are. So that's 4 times 6. So 4 lamps at 6 watts each, that is 24 watts. So we can put 24 in the top of our triangle there. Now we also know that the circuit is supplied by a 12-volt supply. So if we drop 12 down into the volts section, and now we should be able to calculate the amperage, because amperage is the watts divided by volts. So 24 divided by 12, which is equal to 2. So now we know our answer is 2 amps.